All right, time for another video. Last previous video we have been discussing errors, and I actually mentioned something about if you've experienced errors with your programming, especially for experienced or new players. Go ahead and throw it in the comments. Hit the like button if you like. Tell us about some issues you've had with programming, bugs, errors, etc. Maybe I or somebody else that views the stream and stuff can check out the stories you tell or whatnot and can learn from it. But yeah, we have been discussing errors. I went through a lot of errors last time, and we are moving on to debugging. So let's get that started here. So debugging, what is debugging? We know what errors are when we have problems with our program or whatnot, whether it's actually issue with the program or something we put in there. But what is debugging? Debugging is the process of finding and fixing errors or bugs in the program. Bugs are mistakes that make your program crash, behave incorrectly, or give the wrong output. So, when you have errors in your code, um, you can either see them, find them, or something. But the process of going through that and finding those errors, whether the code is outputting improperly, whether the compiler is not running properly or whatnot, that's called debugging. So you got one thing that's errors, and then debugging, which is searching for those errors, whether they're plainly visible or not. Before you start debugging, make sure that your code is clean and organized. Something we discussed in our last video there. Use proper indentation to keep your structure clear. Give your variables clear, meaningful names that describe what they store. Clean code is easier to read and easier to debug. And yes, we kind of mentioned that when we was able to pretty much stack everything into 2 lines or 3 lines or whatever, and stuff. It's a bunch of code. It makes it harder for us to read it, but as far as the compiler is concerned, it can read it all just fine. No issues. The spacing just makes it easier for us. In the section below, we'll introduce several common debugging techniques. Printing debugging. Use cout to print values at different points in your code to see what's going wrong. So it's got a little example here for us. Let's see what this example looks like here. Go and get it typed out. I'm not really sitting in the right position, but that's fine. So we got integer x is 10, int y is 0. I think we had this before. Yeah, we did. And then standard output before division, and then a new line in that, and then I got a comment here. Debug output, and then int z is x divided by y in that, and then got a comment here saying it should crash right here. And then another output, oops, after division, yep, and a new line, and then in that. Okay, so we've seen this one before, but last time it was integer result, so forth and so on, and it was trying to print it out. Let's go ahead and save this real quick, because that's the mistake I commonly make, is forgetting to save. So yeah, we've seen this before and stuff where we're trying to divide 10 by 0, and it's not possible in most circumstances. Let's go ahead and run the code. We should see before and then after. If it doesn't run both before and after, like I said here, it should stop before the after part. So this should print according to what it's saying, or according to my understanding of this, but this will not. So let's see what happens here. Okay, so that's kind of what I thought would happen. Neither one of them printed, and I didn't think that either one of them would print. It states that this, no, my bad. If I didn't have it highlighted, it might have printed. Let's try it again. Yep, okay. So it prints the before. It didn't print the after because this is not possible right here. So in this case and stuff, you're not seeing any errors that are clearly visible, and it doesn't even finish up the program because it stops it before. So that's something I guess you can kind of use if your code doesn't show any actual errors in it or whatnot. Then you can kind of put an output line in certain places and see if it'll print the output line. If it won't, then you know that there's a problem above that output line. Something else that I know you can do is if you do put in new code and it's not working, your program's not working after that, you can comment out the code that you put in there, save it and run it again. And then if it prints, then you know the new code you put in, there's something wrong with it. And in this case, yes, there's something wrong with it. That's something that they may mention here, but I don't know. Moving on, if you don't see after division, which we didn't see that, we didn't see this right here the first time, the program crashes at XY, yes. So we put some comments in there and stuff, and then to see if it runs it and everything runs it. So we've debugged our program and identified the exact line of code that has the mistake in it in this case. Check variable values, print variables to see if they are what you expect. So we got another example here. We're going to change some minor things, but yes. So we have isolated pretty much the problem in this by debugging it. First off, we ran the code. The before division printed, but the after division didn't print. Obviously, the comment that it gave us told us that this line would crash and stuff. So we commented it out, and the after printed, so we know that it's precisely which line it is and what needs to be fixed in this case, or precisely which line it is. Whether you know what needs to be fixed or not is a different story, or how to get the code proper. Which I mean, this is good exercise for me because it's kind of reminding me that I can use comments. I never really did think of the whole idea of outputting something before and after code and see what prints and what doesn't print. So this is kind of new to me, using an output line after a certain line and stuff to see if it prints. If it doesn't, put the output line above it and see if it prints. If it does, then I know I got a problem with a certain line code. But now we're going to do a check variables and stuff. So it looks like X will be the same, but Y is going to change to 5. We're not going to have the output here or the comment anymore. We will keep this, but we're going to get rid of the comment and change this to minus, and then change our Z according to the example to result. We're going to get rid of the comment here because we don't need it anymore either. And then our output's going to change completely here. So we're going to get rid of this and change it to there we go. Result. Oops. Result. And then a new line. It's got a comment that it should result in 5. Go ahead and save it. Run it. And yes, we got the 5 there. So this is just a way to check to make sure that our variables are printing up correctly. So I guess in another sense of words and stuff, if you want to check and make sure that your variables are printing out properly and the expression is printing out properly, if you have more code down here, you can simply put in something that prints just the result right there. And if it prints that but nothing below it and stuff, then that means that this is correct. There's something wrong with. So basically, it's just a process of elimination. In simple words, that's all it is, a process of elimination. Go through, put new code in there. If it runs, then you know the problem is below what code you put in there. If it doesn't run, you know the problem is above the code. Um, which I used to work on cars, and I used to do that all the time. Process of elimination. People would come in all the time. Engine would be running, and they would be hearing a squeaking noise. Well, the very first thing I would end up doing at that case, if there's a squeaking noise underneath the hood or in the engine somewhere and stuff, and it's hard to determine because of how loud it is or where it exactly is, we use the same thing as what a doctor might use, a scope that for doctors and stuff, it checks heartbeat, breathing rhythm, all that sort of stuff. They put it up to your chest or whatnot. With cars, we had the same thing, but it had a needle on it. So we put that needle up against something specific, and that would amplify the sound so we can hear it better in our ears. Um, but if we couldn't pinpoint the spot, then we would do another process of elimination. So if we got a squeaking noise, how many things can possibly squeak? Well, you got a number of bearings in everything on your car, whether it's the wheels, engine, transmission, etc. And if it sounds like it's coming from the motor, one thing you could do is you can take the belt off the engine, start it up, let it run for a couple seconds. If the squeaking noise is still there, then you know it's something else. It's none of the pulleys that run off the belt because none of those things are spinning anymore. So you put the belt back on. But if the squeaking stopped, then you know it's one of the pulleys. So we could just simply take one of the pulleys, turn them. Sometimes you could feel it, sometimes you couldn't. But you could turn it and stuff and feel it, and sometimes it would feel crunchy when you turned it. If it didn't, then it was something else. But it's still the same process. Process for elimination. Eliminating 10 things to narrow it down to one. So, moving on. Expected 15. So in this code right here, you might expect 15 and find out you only get 5, which just means that your uh, arithmetic operator's wrong. And that's what this mentions right here. Using a debugger tool, IDEs like Visual Studio's, Code Blocks, VS Code have debuggers that let you pause your program with breakpoints, which I've done that before in some of the videos, which is this over here. A lot of them, a lot of your IDEs have this over here. Click to add a breakpoint. So when you click on it and stuff, add the breakpoint, then you go in. Actually, I will do that up here and not down here. So I'll launch a debugger, run it. And this is how it works on VS Code right here. So at this point in time, this is what's currently in these locations right here. But we're setting the value to 10. I got a tool thing up here that I can move around, not too far, but I can move it around kind of like a remote. Different options up here as to what I can do with controls. I haven't really explored all this very well. I could restart it, I could stop it, I could continue, and step over. So basically, I skip a line if I want to, and it puts that out there. Or I can restart if I want to, and step into. It kind of does the same thing, but if it's a function and stuff, it'll go line by line. If it's continue or step over, it may skip a line and result whatever. So that's kind of the whole idea of seeing line by line what it's doing. Another simple way of debugging your code sort of thing. And I've used this many times to try to understand code. So not only is debugging a good source for trying to find errors in your code, but if you are like me to where you're trying to learn the code and see what it's doing step by step to try to understand what the keywords are, um, what a function may be doing, what a class may be doing, etc. Pointers, yes. Doing this right here to where you step through the code one by one like a compiler would do, because that's exactly what you're doing is you're following a compiler's route step by step. But note that when you are doing this, if you change the code or anything like this, because the debugger is still running at this point in time, it's not done yet because you've paused it, or also pause the compiler from continuing forward. um, then those changes won't be reflected in this. In fact, it may throw you an error. So this little stop button right here stops it no matter where it is. I can downsize it again right here. I got a terminal down here. Clear it out this way. That terminal, I'm going to go ahead and turn that off. I'm going to run this. Got more option, debug console. Here's a debug console right here where I can scroll through it. I don't fully understand all of this yet. I do know that, yeah, I don't fully understand all this yet. I got a while to go before I understand all this because there's a lot here. But yeah, I've normally gotten 5 different things right here. The one we normally see is a terminal right here. Problems right here when there is a problem, like for example, I do that right there. It pops up a problem. It tells you what the problem is right there. I know that all these IDEs that they mentioned, Visual Studios, VS Code, which is what I have, and Code Blocks, they probably have something set up like this right here. What the output is right here, all that sorts of stuff. So, anyways, moving on. You can pause the program with breakpoints like I just showed you, step through the code line by line like I just showed you, watch variables and find unexpected values. Um, Sorry, I'm hearing something outside. I'm not sure what it is. It sounds like just a real airplane. We got some weather coming through and stuff. I wanted to make sure it wasn't nothing major with the weather. Anyways, so yeah, watch variables and find unexpected values. So yeah, when you get to this line right here, if you were expecting these two to add together and stuff, and it comes up to where when you run this, did I not save it? There we go. When you run this, there we go. I don't have a breakpoint in there. Sorry. So just running through it. Okay. So when you run this and you're stepping through it, continue. Oops. So yeah, you can also play with this just to get used to it, like what I'm doing right here. So you get to the result, and it tells you that the result is 5 and stuff. You said, no, that should be 15. Why is that result 5? Sort of thing. But yeah. Also note that, and I know this isn't mentioned in the material because it doesn't know what the IDE that you're using, but when you do a debug, you end up with this right here, temp code runner file for VS Code, because this is a temporary file that it is creating and stuff to run this right here. Also, you end up with this right here. This is common all the time. Um, Normally, I just end up with this when I'm running the program, but since I've debugged it, it uses JSON right here. This is another form of the code, which is a file that is created for it to run. We'll get more into detail with this later on. I don't fully understand this myself. I do know that when it comes to multiple files, I got to make adjustments in this so it'll work properly. But yeah, for now, until we get farther into details on that, I just move it to the recycling bin. There we go. And that's the normal stuff we have right there for just running the program. Result 5 right there. Debugging adds a little more to it. I believe in order to run the program in its own terminal, you have to actually debug it first, but I'm not 100% positive on that. I always have trouble remembering that sort of stuff because I just haven't done enough of it. So there's a tip right here. Start with 1, print debug. Use IDE tools as you get more comfortable. So I'm not sure what that means. Start with 1, print debugging. Use IDE tools as you get more comfortable with it. Okay, so I'm not sure what that means. Anyways, moving on. Learning from error messages. In C++, compiler runtime errors often tell you what went wrong and where. For example, expected this. Yeah, that's common. It's the harder stuff that it's like pointer stuff and dereferencing that I struggle with. This right here, I've understand. I've seen enough of it to understand it really easy. And it's also mentioning that this is an easy solution. Fix the missing semicolon. Exceptional handling while debugging is about finding and fixing. Yeah, if you have a lot of lines of code and stuff, and you run your debugging program, you can kind of watch what it's doing as it's going through the lines. Some programs will run faster, some will run slower and stuff. But if you can see the line that's getting glitched, you can click on that certain line right there to make a breakpoint for it. Anyways, while debugging is about finding and fixing errors in your code, exception handling is a way to deal with errors while a program is running and run specific code when something goes wrong. Now, I'm not familiar with that per se, because I've never exception handling. Yeah, I'm not familiar with that. That's the part I'm not familiar with. So I guess there's another chapter on exception handling, um, which is actually the next part. So let's go to that next part right there. I think I'll go ahead and cut this video off right there, and we'll pick up right here. We are currently dealing with errors, debugging, going through your programs. This one right here is a simple one, but if I get to where I have uh, several lines of code, hundreds, thousands, tens of thousands of lines of code and stuff, then yes, looking for that specific problem may be quite a bit more difficult. So, but yeah, I know when you do have that many lines of code, your terminal down here and stuff may print out a ton of stuff for errors. And if it does that and stuff, it may be kind of hard to decipher all of them. I have never gotten that far yet in my coding because I'm still just learning the basics. But like I said, we'll end the video right there. We'll pick up with it right here in the next video. If you liked the video, click the like button. If I've said something wrong, like normal, feel free to correct me in the comments, ask questions, leave comments if you want to, etc. And I will see you in the next video.